Hello friends, welcome back. Today I am going to discuss about CPU performance challenges, parallel computing and computer vision. So this particular post is aimed to make some background related to deep learning in edge computing, computer vision, artificial intelligence, and this covers the various industry standards to meet high performance demand of advanced applications. So first of all, let's try to understand the challenges we have. Processor performance challenges. As you know, any application program consists of number of instructions. The primary goal of CPU performance is to reduce the application execution time, which depends on instruction execution time. Instruction execution depends on the CPU clock cycle. So here the primary focus right now on the CPU performance, not the complete embedded system or desktop performance. So based on this, it is obvious that CPU performance depends on the CPU clock cycle. So however, increase in CPU clock frequency is almost stuck now, halted now, and not even reached the 10 gigahertz. So what is stopping this CPU frequency scaling? Let's look into the power consumption formula of a silicon device. So P equal to CB square into F, where F is the frequency, P is the power, C is the dynamic capacitance being switched per clock cycle, and V is the voltage. So you can just look into these two factors, V or F, and interestingly, switching of transistor depends on the charge, which in turn depend on the current, and current is proportional to voltage. So the way that you need a fast switching of the transistor, then it requires like current to reach to that particular level, and so this switching speed frequency is proportional to voltage. Increase in frequency will increase multiple time power consumption. So if we have the voltage increase, frequency increase, so definitely the power is increased, and this resulted the halt in CPU frequency scaling because there is a limitation in terms of physical property, and this resulted industry shift to parallel scaling or parallel computing in the form of multi-core processor, that we know that already multi-core processor concept is in production. So this is one challenge. Another challenge of silicon industry is fading Moore's law. So what is the Moore's law? That Moore's law is the prediction made by Gordon Moore, co-founder of Intel, that number of transistors per square inch on a silicon device will double every 2 years with cost reduced to half. So this was applicable for many years in almost all domains of the silicon, and initially in 1965 he predicted the number of transistors to be doubled every year, and it was modified decade later. So here the exact that what Moore predicted in this particular electronics magazine on 1965. The complexity for minimum component cost has increased at a rate of roughly a factor of 2 per year. Certainly, over the short time, this rate can be expected to continue, if not increase. over the longer time the rate of increase is a bit more uncertain, although there is no reason to believe it will not remain nearly constant for at least 10 years. That means by 1975 the number of components per IC for minimum cost will be 65,000. I believe that such a large circuit can be built on a single wafer. So this was based on the statistics available that particular time, and the prediction based on that. And later he 1975 this was modified, and as I said earlier, so many experts believe that Moore's law has slowed due to physical limitation, and industry shift to low core and IO voltage is helping to reduce power, as I explained earlier, that from frequency scaling to frequency scaling also depends on this voltage and power. And so if voltage itself is reduced, then what will happen? The energy required to switch a transistor from 0 volt to 3.3 volt, or you can say 1.8 volt device, that will be logic 1 in that case, is less compared to 5 volt. Normally in 5 volt logic 1 will be this. So this reflects in various process geometry. You can see 40 nanometer it is 5 volt, and IO core voltage 28 nanometer 3.3, then 14 1.8, and 10 nanometer 1.2 volt. So this is helping. Okay, so this is the another aspect. So as I discussed about shift from frequency scaling to parallel computing, apart from this voltage related thing, the parallel computing is also happening. So let's try to understand the parallel computing trends. So as there are significant developments in various technologies such as high memory bandwidth, 5G technology, you have media processing and artificial intelligence. So the importance of computational power has increased. So when you talk about machine learning, deep data learning, edge computing, those kind of thing, or cloud computing, there basically you need everywhere a high performance device, and this basically lead to several other terms. So I will go through one by one, and based on that Wikipedia, I've taken note of that. And finally the aim is to focus on the latest one and then further do experiment on that. Okay, so GPU is the graphic processing unit. 1970 actually this concept from 1970 is a parallel multi-core computing device for image processing. So it can be part of a CPU, video card, or PC motherboard. It is used in embedded system, mobile, PC, gaming. So everywhere, this wherever that kind of image processing is needed, then it is being used. So GPU contains a specialized hardware for vector graphics. What is GPGPU? GPGPU is also from 1970s. Basically the use of GPU in traditional computing by CPU for applications. So in the applications, if you are using GPU for general purpose, not in image processing only, then it is called GPGPU or GPGP. What is OpenGL? OpenGL is that Open Graphics Library, since 1992, is a cross-language, cross-platform API for 2D or 3D vector graphics. It is generally used to interact with GPU for achieving hardware accelerated performance. So basically your CPU, if you are going to utilize as GPU related features, then OpenGL is that API there. And Microsoft DirectX in 1995 uh, is a collection of APIs for handling tasks related to multimedia. OpenMP, that is Open Multiprocessing, since 1997 is an API which supports multi-platform shared memory multiprocessing programming. So whenever it comes in terms of, let's say, heterogeneous system where there are different kind of devices are there, and overall system performance is being taken by the efforts from all the devices. It can be FPGA or CPU or GPU or any other device. So in that case, if memory sharing is one of the important aspects apart from the multiprocessing. So those kind of things are basically standardized in this particular OpenMP MPI, and it is in C, C++, and Fortran supported. It consists of mainly compiler directives, runtime library routine, and environment variables. Three are the major. It has implemented in many major platforms such as Linux, Windows, Mac OS. Those are the software platforms. Another terminology you will come to know that, like BPU, this is the video processing unit, is used for video encoding and decoding. And if we add algorithms related to machine, this computer vision machine algorithm, we add that computer vision related, then like CNN or this SIP, then it is called that now the processor is coming with these two features together, known as that VPU, that is the vision processing unit. Okay, so that capability of video processing unit and machine vision algorithm. And current trend, so whatever I have, as I mentioned, only the year wise, that what already existed to achieve this kind of parallel computing performance using the hardware or different kind of software interfaces or software implementation. So now what is the latest trend for that? And CUDA, initially this is that since 2007 NVIDIA introduced in the beginning as compute united device architecture, and later they recalled this particular acronym, and it is a parallel computing architecture which provides a programming model for GPU utilization. So it is providing you the programming model for that, and it supports programming language C, C++, Fortran, and environment such as OpenCL, DirectX. What is OpenCL? Is an open computing language, and since 2008, and CUDA basically it is introduced later, and in 2000 days is an open standard for writing programs to be executed in heterogeneous platform, consist of CPU, GPU, DSP, digital signal processing unit, processor, or FPGA. So all these are being used if in a system or making a heterogeneous platform, then there also it it can be used, and it provides that kind of standard, and it supports C, C++, and there is a Python support for this known as PyOpenCL. Py is Python OpenCL. And OpenVX in 2014 is a open royalty free standard for cross platform acceleration of computer vision applications. So this is aimed for embedded and real-time program within computer vision and related scenarios. It uses a connected graph representation of operations. And next, Intel OpenVINO, that is the Open Visual Inference and Neural Networking Optimization. In 2018, it was announced that toolkit, this which is designed to achieve fast track development of computer vision and deep learning at the edge. So computer vision inference and deep learning at the edge, it was earlier known as Intel Computer Vision SDK. It includes optimized calls for OpenCL and OpenVX. This will be one of the toolkit I will be focusing in forthcoming video in this particular series. So based on the above, one thing is common, that apart from whatever the hardware, that whether it is a CPU, GPU or DSP or FPGA, to achieve the hardware level performance, we have still scope of programming languages like C, C++ and Fortran in implementing optimized software to achieve high performance. You might have noticed that C, C++ and Fortran support, and you will see that Intel optimized C math library, Intel Fortran compiler, Intel C++ compiler, that a range of tools being provided by Intel for parallel computing performance. Okay, and thanks for reading Talent, and I am trying to improve usability of my site. Did you find this discussion helpful? If so, please subscribe to YouTube channel Embedkari as well for additional embedded related stuff. Okay, thank you very much.